Pluto is a remote and perplexing, more modest planet that was once a piece of our sun-fueled system's planetary gathering. However, later surprising announcements by prominent astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight with an astounding discovery. They suggested that this cool world is on a potential collision course with Neptune. But how could this happen, and what might be the repercussions of such a giant event? Are we seeing a fascinating cosmic peculiarity, or is there something else to this coming limitless struggle? Join us as we investigate the possible results of a Pluto-Neptune impact. Pluto, a previous planet that was renamed as a dwarf planet in part due to its astonishing orbit, remains a subject of interest and investigation in the cosmic community. According to recent figures by leading scientists, Pluto's orbit is dangerously close to Neptune's, with both Neil deGrasse Tyson and Michio Kaku sounding the alarm about a likely dangerous collision between these two planets that could present a critical risk to Earth. How is such an event even possible? Pluto's orbit around the Sun is unlike any other planet in our nearby planetary system. It requires an amazing 248 years to complete a single orbit. Since its discovery in 1930, it hasn't even finished one full revolution. However, the interest doesn't stop there. Pluto's orbit is marked by its exceptionally elliptical shape, wandering astonishingly from the almost round orbits of the major planets. What makes Pluto's orbit even more astonishing is its inclination, determined at 17 degrees to the ecliptic plane. The manner in which Pluto follows is significantly more extreme compared to other planets. This inclination and elongated nature add layers of complexity to its orbital design. One of the most intriguing aspects of Pluto's orbit is its intersection point with Neptune's path. For about 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, challenging what we might expect from their positions in the planetary system. This prompts the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational effects of other planets. The examination of Pluto's orbit began not long after its discovery. Initially, astronomers attempted to understand its unusual path. In contrast to planets whose orbits lie somewhat near the ecliptic plane, Pluto's orbit stood apart with its steep inclination and stretched shape. The mystery deepened with the confirmation that Pluto's orbit indeed crosses Neptune's. The stability of Pluto's orbit amidst these complexities is proof of the intricate design of space mechanics. The three-body problem in space involves figuring out how three objects, like Pluto, Neptune, and the Sun, move and affect each other with their gravity. It's like attempting to predict where they will go based on where they start and how they pull on each other. In Pluto's case, this problem shows how the orbits of Neptune and the Sun's gravity all interact in a complicated way. The terms libration and resonance libration, along with the VSK oscillation, are part of this puzzle, as indicated by astrophysicists. What's keeping all planets in their orbits is a U-libration. In the specific context of Pluto and Neptune, this term suggests that whenever Pluto crosses Neptune's orbit, it's arranged at least 90 degrees away from Neptune. This spatial division is critical in keeping their orbits from colliding. Resonance libration, on the other hand, refers to the vertical movement of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it's situated entirely above their orbital plane, providing an additional layer of protection from potential impacts. Another significant part of this condition is the VSK oscillation, named after three researchers, von Zippel, Kappas, and LV, who studied how objects move in space. It describes how three celestial objects like Pluto, Neptune, and the Sun pull on each other with their gravity. This pulling affects how they move. In Pluto's case, the VSK oscillation helps us understand why its orbit around the Sun is so unusual. Despite its seemingly turbulent path, Pluto's orbit remains stable for an extraordinarily long time, like billions of years. This means Pluto's venture around the Sun has a kind of order to it, even if it seems unpredictable at first. Predicting limitless events, especially when they involve violent orbits like Pluto's, presents critical challenges. The inherent unpredictability of these systems means that long-term predictions are often filled with uncertainties. While mathematical simulations provide a powerful means to understand and predict the future path of celestial bodies, they also highlight the limitations of our predictive abilities. These models depend heavily on the accuracy of initial conditions and the complexity of the interactions they simulate. Any minor error or deviation can lead to vastly different outcomes, making precise predictions a daunting task. Moreover, the turbulent nature of celestial orbits like Pluto's reminds us of the constantly evolving and dynamic nature of the universe. While we have made significant steps in understanding space, the case of Pluto serves as a reminder that our knowledge of the universe still remains limited. Understanding the gravitational effects of the giant planets on Pluto's orbit provides valuable insights into the broader dynamics of the solar system. It shows how the presence and position of each planet can create far-reaching effects on the stability and behavior of various bodies within the system. So why are prominent astrophysicists recently raising concerns about a potential impact between Pluto and Neptune? Despite all these intricate forces trying to prevent such an event from happening, Neil deGrasse Tyson, a prominent astrophysicist and a key figure in advancing cosmology, offers an interesting perspective on the mysteries of our nearby planetary system, particularly the captivating case of Pluto. Tyson, known for his role in the renaming of Pluto from a planet to a dwarf planet, provides insightful commentary on the evolving nature of celestial mechanics and the public's interest in the unexplored realms of space. Tyson's position on Pluto's renaming is grounded in the ever-growing knowledge of our solar system. He sees the renaming not as a demotion but rather as a significant adjustment in alignment with our developing understanding of the many bodies orbiting our Sun. Tyson's approach to celestial mechanics is one of continuous learning and transformation. He sees the complexities of orbits like Pluto's as a sign of how much there is still to discover in space. The interest in these questions, especially the potential interactions between Pluto and Neptune, highlights the dynamic and unpredictable nature of our nearby planetary system. His work stresses that the more we uncover about space, the more questions arise, pushing us to explore further and refine our understanding of the universe. Michio Kaku, another respected physicist and futurist, offers a different yet complementary perspective on the mysteries of space, focusing on the often tumultuous forces that shape our universe. Kaku is known for his ability to connect complex scientific ideas with visionary concepts, making him an important voice in discussions about celestial mechanics and the broader implications for humanity. Kaku's perspectives on Pluto and its orbit emphasize the need for continuous observation and advanced modeling to predict and understand potential astronomical events. He sees the interactions between celestial bodies as an important area of study, not just for academic interest, but for practical implications. The potential collision between Pluto and Neptune, for instance, isn't just a theoretical situation but a reflection of the dynamic and often violent nature of space. Kaku's futurist perspective urges us to consider the broader implications of such events, from their impact on our understanding of the solar system to the potential need for future space interventions. His perspective highlights the significance of being prepared for the unexpected in space. Kaku suggests that the more we understand the forces at play, the better prepared we will be to navigate and potentially mitigate the effects of cosmic events. Both Tyson and Kaku's viewpoints converge on the idea that space is a domain of boundless discovery and that our current understanding, while significant, is still limited. Their emphasis on the need for ongoing exploration and advanced modeling reflects the evolving nature of space science. They highlight the importance of not just understanding celestial mechanics as they are now, but also anticipating how they may change in the future. The potential impact scenario between Pluto and Neptune serves as a case study for the broader challenges and opportunities in space exploration. It emphasizes the need for effective scientific inquiry, advanced technology, and a willingness to revise our understanding as new information emerges. For Tyson and Kaku, the mysteries of space, exemplified by Pluto's orbit, are a call to action for the scientific community and humanity at large to keep pushing the boundaries of our knowledge. There is a general scientific consensus that, for the foreseeable future, the orbits of Pluto and Neptune remain stable due to their mean motion resonance and the various gravitational forces acting upon them. Therefore, a direct impact between Pluto and Neptune is extremely unlikely. However, the complexities and potential perturbations in orbital dynamics still mean that astronomers should continue to monitor and study these celestial bodies to better understand their long-term behavior and any potential risks they may pose. While the possibility of a Pluto-Neptune collision is largely theoretical and considered unlikely with current understanding, it highlights the importance of continuous research and observation in space science. Advances in technology, including more advanced telescopes and virtual simulations, will help astronomers refine their models and predictions, ensuring that we stay abreast of the dynamic and ever-changing nature of our nearby planetary system. Tyson's perspective on Pluto's renaming and Kaku's emphasis on the unpredictable nature of celestial mechanics both underscore the need for ongoing investigation and a flexible understanding of our universe. The potential impact scenario, while highlighting the dynamic and complex interactions within our nearby planetary system, ultimately reminds us of the vast yet still unclear domains in our understanding of space. Through continued research and observation, we strive to unravel these mysteries, ensuring that our knowledge keeps pace with the ever-evolving universe. Pluto continues to captivate scientists and space enthusiasts alike with its distant, mysterious nature. While its status as a dwarf planet has long been debated, its orbit and peculiar characteristics keep researchers engaged. Recent developments suggest that while the chances of Pluto colliding with Neptune remain slim, the universe holds many surprises. Through the tireless efforts of scientists, we can continue to explore the depths of space, finding new ways to anticipate, study, and understand the universe. The dynamic interactions between Pluto, Neptune, and other celestial bodies offer a fascinating glimpse into the complexity of space, urging us to continue pushing the boundaries of our knowledge. As we continue to explore the dynamics between Pluto and Neptune, it's essential to highlight the significance of their relationship in the context of celestial mechanics. The idea that these two planets might one day collide has sparked interest not only in the astronomical community, but also among those fascinated by the unpredictable nature of our solar system. However, despite the potential for such a cataclysmic event, it's important to reiterate that current models predict a stable and highly unlikely collision between Pluto and Neptune in the foreseeable future. This notion rests heavily on the intricacies of gravitational interactions and orbital resonance that have allowed both planets to coexist in a delicate cosmic dance for billions of years. Pluto's unique orbit is heavily influenced by the gravitational pull of larger planets like Jupiter and Neptune. These giant planets exert significant forces on Pluto, altering its trajectory and stabilizing its path despite the eccentricities in its orbit. The concept of orbital resonance is vital in understanding how Pluto and Neptune avoid collision. In this resonance, Pluto and Neptune move in such a way that their orbits never cross paths in a dangerous manner. This resonance occurs in a 3:2 ratio, meaning that for every 2 orbits Neptune completes around the Sun, Pluto completes 3. This orbital lock ensures that when Pluto comes close to Neptune's orbit, they are always positioned in a way that keeps them at a safe distance. This gravitational resonance is not a simple coincidence, but rather a result of billions of years of fine-tuning between these two bodies. In fact, such resonances are common in the solar system and play an essential role in the stability of many planetary orbits. Jupiter's influence on the asteroid belt, for example, helps to prevent collisions between asteroids by either scattering them into stable orbits or ejecting them from the solar system entirely. Similarly, the complex interaction between Pluto and Neptune is part of a larger cosmic balancing act that allows these two bodies to maintain their respective positions without significant disruption. Furthermore, the role of smaller bodies in the Kuiper belt, the region where Pluto resides, is often overlooked in discussions about Pluto's orbit. These objects, which include icy comets and dwarf planets, interact with Pluto in ways that can subtly shift its trajectory over long periods. However, the gravitational forces exerted by these smaller bodies are not strong enough to significantly alter the orbit of Pluto in a way that would lead to a collision with Neptune. Still, these interactions offer insight into the complexity of orbital dynamics and highlight the delicate balance that exists within the outer reaches of our solar system. Beyond the science of orbital mechanics, the potential for a Pluto-Neptune collision raises questions about the nature of celestial bodies and the long-term evolution of our solar system. Will the solar system continue to be as stable in the distant future as it is today? As our understanding of planetary formation and dynamics improves, scientists are beginning to consider scenarios in which the orbits of distant bodies might change due to influences from other stars or the Sun's evolution. While these possibilities are speculative, they underscore the importance of studying the long-term behavior of planetary bodies to gain a better understanding of the processes that shape the solar system. The possibility of a Pluto-Neptune collision also invites us to think about the broader implications for space exploration. While such an event is unlikely to occur anytime soon, it highlights the dynamic and ever-changing nature of space. The tools and technologies that scientists use to study the solar system, such as space telescopes, computer simulations, and gravitational wave detectors, are continually evolving. These advancements allow astronomers to refine their models and gain a deeper understanding of the forces at play in the cosmos. For instance, missions like NASA's New Horizons, which provided the first detailed images of Pluto in 2015, have given scientists a much clearer picture of Pluto's surface and its interaction with the solar wind. Data from such missions can also help refine our understanding of the forces at work in the Kuiper Belt and beyond, offering new insights into how objects in these distant regions of space behave over time. Moreover, the study of Pluto and its orbit highlights the importance of international collaboration in space exploration. Observatories around the world work together, sharing data and research findings to build a more comprehensive picture of the solar system. This spirit of cooperation, combined with the growing capabilities of space agencies like NASA, ESA, and others, is vital for addressing the many unanswered questions about our cosmic neighborhood. As we push further into the exploration of space, the prospect of discovering more about Pluto's place in the solar system will continue to captivate scientists and the public alike. While the likelihood of a catastrophic collision between Pluto and Neptune remains exceedingly low, the continuous study of their orbits offers valuable insights into the workings of the universe. It also serves as a reminder that even in the most stable and predictable regions of space, there is still much to learn and uncover. Through careful observation, simulation, and international cooperation, we will undoubtedly continue to expand our understanding of the solar system and the many mysteries it holds.